Okay, good evening, ladies and gentlemen. This is again Professor David J. Delos Reyes. I am now testing my ETA, ATX power supply. Okay, I made some research. Okay, to test if this what you call this power supply is alive or not. The power supply for computers are actually so many. It's like this. It's a 24-pin thing. And for modules like this, uh, for us to know if the power supply is alive or not, there is the so-called trigger thing. And I made a research. And to activate this power supply, if it's alive or not, it's alive because this green LED is alive, right? And as you can see it, okay, the electric fan is rotating. So actually the power supply is alive. I've made the what you call this measurement already. So what I did is that for computer power supplies there is this so-called trigger thing, and you see this green terminal. That's the trigger terminal, and it says from the concept. The concept says that to trigger to make this power supply alive, the power supply for computers, you should short out this green to any ground thing. So I short out this green with this black thing here by using this one. That's the shorting thing. So when I short it out, okay, I plug it in, okay, the power supply is alive. So as you can see it, the electric fan is moving, right? So regarding the measurement of the voltages of the colored terminals, I've done this one already. I've done this one. They are all alive. So I will just read what I have got. For the red thing is 5.14 volts. This two red thing here, three actually red terminals in succession, right? It corresponds to that three there. So when I measured it, they are all 5.14. That's fine. Because this 5.14 is actually the one that powers up the microprocessor. 5.14 is just good enough. If it's less than 5, there's a little bit problem. But 5.14, when the microprocessor draws some current, it will go down to around 5 volts. So the requirement for microprocessor is 5 volts, so it's fine. So the three red things here in succession, the reading are all 5.14 volts. Of course, all the blacks are zero because the blacks are all ground. And for the blue one, there's a blue one here. There's that blue, that blue. That blue terminal, it got an 11.99. That's almost what they call this 12 volts, right? There's a 12 volt for computer power supply. So 11.99, that's fine. For the orange thing here, the orange thing, the voltage is around 3.323. I think those are the voltages for the memory RAMs. Okay, memory. So the orange, I got three orange, one orange over here, but on the other side, there are two successive oranges over here, and the reading are still 3.323 over here. Right? Then the next one, we got the red here. The reading is 5.14. We got the red thing. What's next? We got another red. It's also 5.14. That's fine. And the next one, this is gray. This is gray. The gray one is 4.75. Oh, this is a little way off from, I think the proper voltage for this one is 5 volts, but it's not far from 5 volts. So I hope the uh, detector of the computer will sense that this is still a fine voltage to operate the computer. And the black one here, the one beside it is 5.10. I don't know why this is 5.10 because black supposed to be is what they call this a 0 volts. Then we got the yellow, two yellow and orange over here. They are all good. 11.94, 11.94, and 3.323. Okay, so the only voltage that is a little bit way off from the normal voltage of the computer is this 4.75 over here. And this black here, I don't know why this is 5.10. So I will try to install this one. Then I will try to power up the motherboard. I hope it works fine. But just in case it does not work, I will have to troubleshoot this 4.75 and this 5.10 here. Because this black 5.10 here is a black terminal. The voltage should be a 0 voltage. Okay, but for this computer, it's right now it's 5.10 because the last time around I was not able to power up this one. Okay, power supply for computers are actually triggered by through two terminals, unlike on the analog circuits. The power supply and the main circuit is not triggered by a certain thing, you know. So once the power supply is energized, it's all connected to the main circuit. So you will know what's wrong with there. But for digital like computers, right? The power supply is actually there's the so-called trigger thing, and the trigger thing for this one is by shorting out this green, and to any ground one which is black. So I was able to make this power supply alive by triggering this power supply. I studied it. Okay, the concept is to trigger the power supply of computers now, you must have to short out the what they call this, the green terminal and any black thing to make it alive. So as you can see it is alive. And from my readings, the voltages coming out from the different terminals are alive. This is the only thing that is a little bit awkward, this 4.75 and this 5.10. Okay? And actually, the power consumption at plug-in is just, I got a kilowatt hour meter over here, power meter here. It's just 180 milliamperes at plug-in. So actually, computers at plug-in still consumes a very minimal current. Okay, it's just minimal. It's just the what you call this current due to the so-called trigger thing plus the microprocessor thing. Okay, good evening from Los Angeles. This is Professor DavidJDelosReyes. Hallelujah, because we were able to power up or make alive this power supply by shorting the green and the black wire. Good evening from Los Angeles.